Alright, in this video we are going to look at a snapshot of some different linear topics. The first thing we're going to look at is solving some different types of linear equations. So first of all, let's go ahead and make it easy and let's look at some ideas behind one-step linear equations. So a one-step linear equation may be a problem that looks a little like this, where we have 9n minus 15 minus 4 times my 2n plus 1 equals 7 minus 11. Now, some may look at this and go, oh, no, there's a lot more steps to this than just one step. Well, what we're looking at in terms of one step is what is going on with your variable. Meaning, once you combine all of your like terms, do you have to do extra steps to get your variable isolated? In this case, you won't, and let me show you exactly how that happens. First and foremost, we have to take care of your parentheses. You're going to kind of work very similar to the order of operations. So we are going to take and distribute this 4, so this entire 4 term, including the negative, we are going to distribute through those parentheses. And so here, we're going to have my 9n minus the 15, because we haven't done anything with that yet. This negative 4 distributes through, so this becomes minus 8n minus 4. And of course, on this other side, we can quickly do the math. 7 minus 11 is negative 4. Now, if you look, we need to combine our terms that are here. So we have 9n and we have minus 8n. So when we combine those, if we were just look just at this, you would see that we end up with n. And then we would have minus 15 minus 4 equals negative 4. So here what we need to do is we can combine the 15 and 4 on this side. So we have n minus 19 equals negative 4. I then have to take this 15 and I need to move it across my equal sign. Because it's already negative, I have to add it to my other side. So when I add it, I end up with n equaling 15. Now again, the reason why this is considered a one step is because when we combined our two variables, notice there's nothing else I had to do. My n was totally isolated. Okay, so therefore we've got a one-step equation. Now let's go ahead and take a look at a different equation. Okay, so what happens if I have this one, where I have 5 over 12 is equal to x plus 8 over 15. So the first thing I want to do is I want to isolate my variable. And I'm going to do that by taking this 8 over 15 and I'm going to move it across my equal sign. Because it's positive, to move it this time says I have to subtract. So when I subtract, I'm going to end up with 5 over 12 minus 8 over 15 is equal to x. Now my x is totally isolated. There's nothing else I have to do, but I do have to simplify my fractions. So in this case, one of the things I want to look for is I want to look for that least common denominator value. Between 12 and 15, my least common is going to be 60. However, one thing you can do is just simply identify the common denominator. Okay? So, as a side note, to identify a common denominator, not necessarily the least, okay, you would simply multiply all denominators together. This will actually give you a common denominator that you could use in order to solve your problem. You would just be giving yourself an extra step in terms of reducing at the end. In this case, we can go ahead and use 60. So if I look at 12, I have to look at what do I need to do to 12 to make it 60. So in this case, it's going to be multiplied by 5. So this is going to be 5 times 5 on the top. I'm subtracting 8, and then what do I have to do to my 15? Well, I multiply it by 4. That puts the whole thing over 60. So in this case, I'm going to have 25 minus 32 all over 60. So x is going to be negative 7 over 60. Now, because I used my least common, there's no other reduction or simplifying that has to be done. However, had I used something other than my least common denominator, I'd have to simplify this fraction. Okay. Let's look at one that's, again, a little bit more in depth here. So what happens if we had 3/5 of n minus 5 plus 2/5 n minus 7 is equal to 5 over 8 plus 3 over 4. So with this one, the first thing that we would do again is we would identify a least common denominator. Now the reason we want to do that is because I have 4 denominators that I need to get rid of. So we are looking at the 5, the 8, and the 4. So I want to know what's common there between my denominators. So in this case, your least common is going to end up being 40. Okay? But once again, one thing you could do is multiply your denominators together and use that value. So here, what I'm going to do is I'm going to take my entire equation, so I'm going to do it this way just to save on space. I'm going to take this entire equation and I'm going to multiply it by 40. So what it means is that this 40 is going to multiply just to the 3/5. It's going to multiply over here to the 2/5. It's going to come over to the 7. And then it's going to multiply to my 5/8, and it's going to multiply to the 3/4. Okay, so we are going to multiply it to everywhere. So essentially, this is going to become 40 times my 3/5, and then I have the parentheses, but I'm not multiplying into this, so I'm going to leave it blank for a minute. So then this is plus 40 times my 2/5 plus my 40 times that negative 7 is my 40 times the 5/8 and my 40 times the 3/4. Now I wrote it out this way, just showing you another way that you could work your workout if you needed. This allows you to cancel and show your steps a little easier. So my 40 and my 5 go away and leave behind an 8. Again, 40 and 5 go away, leave behind the 8. 40 and 7 are going to just multiply together. 40 and 8 go away, leave behind a 5. 40 and 4 go away, leave behind a 10. So 8 times 3 is going to give me 24 times n minus 5. And then here I'm going to have plus 16n, because 8 times 2. This is going to be minus 280 is equal to 5 times 5 is 25. And here this is going to be plus 30. 10 times 3 is 30. Now that that's finished, I have to distribute this 24 into the parentheses. Okay. So by doing that, that gives you your 24n minus 120 plus 16n minus my 280 is equal to 55 by combining these two values. Now in this case, we would take the 24, so we would take this 24n and the 16n and we'd combine them together, and in this instance we're going to end up with 40n. We would then take your 120 and your 280 and we'd combine those two together, and this is going to end up giving us minus 400 is equal to 55. We'll move the 400 over, so just like before, when we move this, we have to pay attention to its sign. We want it to go across the equals. Because it's already negative, to move it says we have to add it across. So we get 40n is equal to 455. We, in this case, have a second step, and this is a multi-step. What happens here is we need to divide this 40 out. So my n is going to be the 455 divided by my 40. Now once we do this, we always need to reduce. So we want to look and see if any of my factors of 40 will come out of 455. Well, since my numerator and denominator end in both a 0 and a 5, we know we can divide a 5 out. Therefore, n is going to be 91 over 8. Now, there's nothing else that I can do to 91 or 8 that is going to give me a common or reduced value, so that is our n value. Alright, let's look at another one here. What happens if we had negative 5 over 6y is equal to 3 over 4? Well, there are two ways, or two big ways, that we could approach this problem, and so I'm going to go ahead and show you both ways. So the first way, or way number 1, what we're doing here is we are going to solve by lowest common denominator. Okay? So I have a 6 and I have a 4. So in this case, my LCD is going to be 12. So I'm going to take that 12 and I'm going to multiply it by my entire equation. So negative 5 over 6y is equal to 3 over 4. When I multiply the 12 in, this is going to become 2 times my negative 5y, and this is going to become 3 times my 3. So we're going to take the 12 over 6 and 12 over 4. So here we end up with negative 10y is equal to 9. So y equals negative 9 over 10. Now let me go ahead and show you the second way. So way number 2 is going to use the proportions. Okay, so So to use proportions, what it means is that we are looking at the problem through the eyes of negative 5y over 6 is equal to 3 over 4. And when we do that, we can do what's called cross multiply. So you're going to take the bottom of the left and multiply it to the numerator of the top. So we're going to cross multiply. So we're going to take the 3 or 6 times 3, and then we have to do it to the other side. We're going to take the top of the left and go to the bottom of the right. So in this case we would have negative 5y times 4. So here 6 times 3 is 18. Negative 5 times 4 is a negative 20y. We got to get y by itself, so this becomes negative 18 over 20 equals y. And at this point, we must reduce. So when we reduce, here we can take a 2 out of the top and bottom, so we get negative 9 over 10 is equal to y. And if you look, you can see that both of these give you the same solution. So it doesn't matter which way you chose to solve in this particular instance, and that's only because notice my variable term and my other side, my constant term, they're single term sides. Okay, now if this problem had looked like the one we just did, meaning this one, where we have multiple terms on either side of the equation, you cannot cross multiply. Okay? So we use that proportion purely because we have single terms on either side. Alright, let's take a look more closely at some more multi-step equations. So what happens if I had something like this? 3 minus 4 times 2x plus 3 is equal to a 12x plus 5 times x minus 8. Now the reason these are more multi-step is because if you notice, we've got x's kind of on both sides of your equations, which means you're going to have a few extra steps to get your x isolated than we had in the original. So here, one of the first things that we have to do is we need to take this negative 4 and we need to distribute it through the parentheses. We also need to take this 5 and distribute it through your parentheses. So here we're going to end up with 3 minus 8x minus 12 is equal to my 12x plus a 5x minus 40. Now we need to start combining. The first thing we need to do is start working on our x's. So we're going to combine these terms together, and we're also going to combine our constants over on this side. Okay. So here we're going to end up with a negative 8x minus 9 is equal to 17x minus 40. Now I have an x on either side of my equal sign, so the trick I like to use is this: keep your x positive. So I'm going to look, and my 17 is a much bigger number, but my 18 is my 8x is negative. So I'm going to take this 8x here and I'm going to move it to the other side of my equation. Since it's negative, to move it I have to add. So I'm going to add 8x to both sides. So this is negative 9 is equal to 25x minus 40. I now have to take my 40 and shift it over. Again, it's negative, so I have to add So negative 9 plus 40 is going to give me a 31 equals my 25x. Get x by itself by dividing. 31 over 25 is equal to x. Okay, multi-step problem. Alright, let's go ahead. Let's take a look at one that is going to be slightly more complicated. What if we had 9/10 x minus 5 plus 2/3 x is equal to 5 over 6 plus 11 over 15 x minus a 4x. So again, like before, one of the first things we want to do is identify that LCD number. So in this case, just like before, we want to look at these denominator values. And so what we have here is we have a 10, a 3, a 6, and a 15. So if we're looking at these four values, one of the things that we have in common between all of them is 30. So we can go ahead and use 30 as that least common denominator. And just like before, I'm going to take my entire equation and multiply it by that 30. So that's going to be 30 times my 9/10 x. So in this case, 30 over 10 becomes 3. So this is 3 times 9x. I'm going to have minus 30 times 5. This is going to be plus 10 times my 2x. And this is going to equal 5 times 5. We're going to have plus 2 times 11x minus 30 times my 4x. Okay? So here 3 times 9 is going to give me 27x minus 150 plus a 20x equals 25 plus a 22x minus 120x. Now's where the fun begins. Just like before, we are going to combine our variables on the left side, and we're going to combine them on the right. So in this case, we've got 27x plus 20, so this is going to give you a 47x minus 150, and this is going to be 25, and we're going to have minus 98x. Now again, I want to make sure that my variable stays as positive as possible, so I don't have to deal with any kind of negatives. So I'm going to go ahead and take this negative 98, since it's the bigger digit, but it's negative, and I'm going to shift it over my equal sign. So I'm going to add it to both sides. So here this is going to be 47 plus 98. It's going to give you 145x minus 150 equals 25. I'm going to take my 150 and I'm going to move it. Again, I have to add. So this is going to give me 145x is equal to 175. So my x is going to be 175 over 145. Again, I know that I can reduce, so I'm going to go ahead and do that. And here we're going to end up with x being 35 divided by 29. Okay, now I want to talk a little bit about doing some applications with your linear equations. So the first thing I wanted to look at are applications where we have to unpack our sentence. So for example, if we had 4 times the difference of a number and 12 is equal to 16 less than twice the number. The question says find the number. Now these problems, I know for a fact, give students a lot of trouble. So let's break this down. We have a lot of clues in this sentence that we need to kind of pay attention to. First and foremost, the biggest clue that we have right here is we have the difference of. Okay? So the difference of, this means subtract. And when we're talking about subtraction, we mean parentheses subtract. The difference of means parentheses, okay? And we're subtracting. Well, what are we subtracting? We're subtracting what comes next, okay? So we're going to subtract a number, so this would be your variable. For example, x. And obviously 12 would be the number 12. So this and right here is going to be essentially like your sign. So we have x minus 12 because of the difference. Now if we look at the beginning, we had 4 times. So this would be 4, and then times is the same as multiply. Okay? So if we just look at this first piece, when we write it down, we would write 4 parenthesis x minus 12, close parenthesis. 4 times the difference of a number and 12. Okay. Now this next piece is pretty simple. Right here we have is equal to. So this is your equal sign. Okay, so that denotes that you are done with the one side of your equation and you can move on to the next. Okay. So when we move on to the next, we need to look at what exactly is being said. And we have, again, quite a few key phrases that are being used. First we have 16. Obviously this is going to be the number 16. But then I have less than. Okay? Less than, this right here, this is called a turnaround. And less means subtraction. So the turnaround phrase means what comes first, this part down here is what gets written first. Okay? So the turnaround says, when we look at this piece here, this comes first. Twice is the same as 2 times, or 2 multiply. The number is referring to whatever you determined up here. So this would be your variable, and in this case, x. Okay? So this is going to come first. So the way that this works is you would write this piece, so 2x, less gives you your sign, subtraction, and then the number 16. Once you break your sentence all the way apart, now you can simply just go in and solve it. So here we're going to distribute this 4 into your parentheses. So we have 4x minus 48 is equal to a 2x minus 16. I'm going to take my 2x here, and I'm going to move it over because it's positive. This means I have to subtract. So this is going to end up being a 2x minus my 48 equals negative 16. I now need to move my 48 over by adding. Okay, again, its sign was already negative, so I have to add it. So this becomes 2x is equal to 32. So x equals 16. So in this case, the number is 16. Let's decipher another one. So we have one integer is 5 less than 6 times a second integer their sum is 58. What are the integers? Okay. So here I have two sentences. This means I have two separate equations. Okay. So we right here have one integer. So this is going to be a variable. Let's call it x. Just like before, I have this is. Okay? So this piece right here is, this is going to mean equal. So this is your equal sign. And then I have 5. This right here is my turnaround phrase. Less means subtraction. So then I have 6 times a second. So right here where it says second integer, this means a different variable. Let's call this one y. So if I break apart or write down this sentence, what I have is I have one integer, so x is equals 5 less than 6 times a second integer. So 6 times is going to be 6y minus 5. Now this is a whole separate, so we would totally break this. This right here is a separate equation. So there right here, this is referring to your variables from your previous sentence. So there is talking about, in this case, x and y. Here we've got sum. Sum is addition. The is right here is your equals 58. So my second equation is going to be x plus y equals 58. So what I have to do is I have to use these two equations together to solve for my variable. So the first thing that I'm going to pay attention to is the fact that I right here know what x equals. X is equal to 6y minus 5. So I can plug that in. I can say 6y minus 5 plus y is equal to 58. I can take my two variables and combine them, which gives me 7y minus 5 equals 58. I can take this 5 and move it over. Because it is subtracting, I need to add it. So this becomes that 7y is equal to my 63. Divide everything by 7 and I get that y is equal to 9. Now this is only half the solution. You at this point still need x. Okay, all we did is solve for y. Now we can come right back up here to the fact that we now know that x is equal to this equation. So we can use that x equals 6y minus 5. Well, we know that y is 9. So we would say that x is going to be 6 times 9 minus 5. So x is equal to 49. Okay, let's take a look at a problem here. So this says Susan has to buy a dress and shoes for a party that she was attending. The shoes cost $35 and 10 cents less than the dress. The total cost for both was $162. What is the cost for each item? So in this case, what we're looking for is we are looking at the fact that we have a total equaling your shoes plus your dress. Now we know that the total is 162. So this is $162. We also know that the shoes cost less than the dress. So your shoes equals your dress minus 35.10. Okay. So now that we know that, we can use the idea of your two equations in order to solve. Okay. So first of all, let's go ahead. Let S equal shoes and let D equal your dress, just to make it a little bit easier. Our two equations are going to be that S equals D minus 35.10 and S plus D equals 162. So this is just like the problem we just did. We know what S is, so we can plug that in. So D minus my 35.10 plus D equals 162. So 2D is equal, or minus my 35.10 is equal to 162. My 2D is equal to 197.10. So my dress cost is going to be $98.55. If my dress costs $98.55, then my shoes equals $98.55 minus $35.10. So my shoes are going to cost $63.45. Now you can check your work by simply adding these two prices together and seeing what you get. Alright, now let's say, for example, that you went into a store, you needed a new TV, and you saw that there was a sale of 35% off. Okay, so that's your discount, 35% off. You paid $1,984 for your TV. Okay? The question would ask you, what is the original cost of the TV? Okay? So the way we essentially find it is we know what we paid is going to be your original cost minus the discount. Well, what we paid was $1,984. That's what we paid. We do not know the original, but we do know the discount was 35%, so 0.35. Whenever we do a discount, you always have to take that percentage by multiplying it with the original cost. Okay? So once we figure that out, what we have to do here is we have to combine my x terms together. So in this case, we end up getting 1984 is equal to 0.65x. We have to divide everything by the 0.65, and you're going to end up with $3,052.31 equals x. Okay, so that is your original cost of the TV is $3,052.31. Another thing that we do with some linear type algebra is we use the ideas behind proportions and ratios. Okay. So first of all, when we're looking at a ratio can be written in a couple different ways. For example, you may have to find the ratio when you have 24 to 18. Okay, so what this means, or what this is telling you, is that this first term is your numerator, and this back term here, this right here, is your denominator. So what we would do is we would have 24 over 18. Now that is your ratio, okay? But like with everything, once you write your ratio, you then must reduce. So in this case, my ratio would reduce down to 4/3. If we look at it again, I can do it with fractions. What if I had 9/14 to 7/20? Okay? It's going to be the exact same thing, where this first fraction is your numerator. Remember, numerator is the top. And the second fraction here, this one, would be your denominator. In other words, the bottom. So we would set up our ratio using the first fraction, 9/14. I like to put a big ratio bar just so that I keep straight that I'm dealing with fractions, and then put the denominator in, 7/20. Now with this, we have to use our fraction rules. So remember, your fraction rules say that we don't like to do fraction divided by fraction, so instead we would keep the top, change to multiplication, and flip the reciprocal of the bottom. In this case, we would then reduce it down. So if we're looking at 14 and 20, these can reduce. Okay, divide out 2, so this leaves a 7 and a 10. And in this case, we will end up with 90/49. Now this idea helps us get into rates. Okay? A rate is very similar to a ratio, with one difference. It usually has some form of a label. So for example, if we have that a car can travel 310 miles in 4 hours, the question might say, find the speed. And then it's going to tell you how to label it. And in this case, it would say miles per hour. So these are usually broken up into a couple of parts. So your first part usually asks you to write your rate as a simplified fraction. What this is wanting you to do is it's wanting you to just simply put the information how it needs to go. So we want miles per hour. So what this is essentially telling us is, this is telling us that your miles here is going to be your top, and the hours here is going to be the bottom of your ratio fraction. So miles per hour says that we have to take 310 miles over 4 hours. Now once we set up the ratio, we need to reduce. Okay, so in this case, 310 over 4 is going to reduce down to 155 miles over 2 hours. We're not doing any solving here, we're just simply looking at the fraction. Now the second thing that you're usually asked for is to actually find the speed or the value. So here, this is where we would use the decimal. So we have 155 divided by 2 miles per hour. So this is going to be the same as 77.5 miles per hour. Okay, rate. Now the other thing that we can do is we can do it with money. So think about shopping. What if we had a 16-ounce can of pickles is priced at $2.89. We also know that a 10-ounce can of pickles is priced at $1.79. Okay. The question wants to know which is the better buy. So the way that we find that out is we have to look at each individual. So I have 16 ounces at $2.89. So most of the time, the way we would set up this ratio is we would have dollars over amount. Okay, so we're looking at how much, say, per ounce in this case. So the first one I have, let's call it can A, is going to be $2.89 per 16 ounces. So we want to know what is the cost per ounce. So we would go ahead and divide $2.89 divided by 16 gives you 0.181 per ounce. Okay, and this is your cents. When we're looking at can B, here we would have $1.79 per 10 ounces. When we divide that one out, we're going to have 0.179 cents per ounce. So to know which is the better buy, you want to look at which one is cheaper. So we have 18, a little over 18 cents, and we have a little under 18. So set 0.179, 0.181. So in this case, we would say that the better buy is your 10 ounce for the $1.79. Now that's just running comparisons. We can also do some solving. So if we want to solve with our proportions, what we're looking at are proportions where we have, say, a fraction on either side of an equals, but it's somewhere we have a variable. So in order to do this, we are going to use cross product. So if you remember from earlier, cross product says we're going to take the bottom of one side to the top of the other, and we're going to take the top of the one side to the bottom of the other, okay, and basically do what's called the cross product across the equal sign. So here we're going to have 11x is equal to 12 times 6. So in this case, we'll solve 11x is equal to 72. So x is equal to 72 over 11. Now notice I used a simplified fraction. When you're working with proportions, never use decimals unless your problem starts with decimals or the directions specify to use decimals. If you don't see one of those two things occurring, then usually you are wanted to reduce and simplify your fraction as far as it can go. Now let's look at another one. What if I had negative 7 over 2x minus 5 is equal to 9 over x plus 5? Now, if you look very carefully, notice I have a single fraction on either side of my equal sign. So we are still going to be able to do our cross product. So in this case, we're going to end up with negative 7 times x plus 5 is equal to 9 times 2x minus 5. Once we have that, we can go ahead and distribute through on both sides of my equation. Okay, so we're going to go ahead and distribute. So in this case, we get negative 7x minus 35 is equal to 18x minus 45. I want to keep my x positive, so I'm going to take my 7 and I'm going to shift it. Since it's negative, I have to add. So this is negative 35 is equal to 25 minus my 45. I then have to take this 45 and move it. Again, because it's negative, I have to add. So I end up with 10 equals 25x. Get x by itself. So x is going to be 10 over 25 and reduce. In this case, we end up with 2/5. Alright, what if we have a word problem? A car travels at 45 miles per hour. It increases by 3 miles per hour every 2 seconds. By how much will the speed increase in 5 seconds? How fast is the car traveling? So in this problem, we actually have a proportion embedded, and where it's embedded is right here when it starts with increases by 3 seconds and through to your question. So that is actually your proportion. So this first sentence, if we break it apart in half, this first sentence is actually your first proportion. You would have 3 miles per hour in every 2 seconds of travel. Now, the question is going to be your second proportion. Now, the question wants to know how much. So we have x. We don't know how much it's increasing, but we do know it's happening in 5 seconds. So there's the proportion that we have to use. So in this case, we would have that 2x is equal to 3 times 5. So 2x equals 15. So x equals 15 divided by 2 miles per hour, which in this case is going to be 7.5 miles per hour. Now with that, we also have to answer the secondary question, which says how fast is the car traveling? To answer that question, you have to take where it starts, so we know that it's traveling 45 miles per hour, and you have to add in the new speed, 7.5 miles per hour. And that is going to give you its new speed, so 52.5. So your answer here would be, after 5